Hello everybody, welcome back to our BIM series, and from this session onwards we'll be diving into the structural modeling in BIM. But before we get started with the structural modeling in BIM, we need to have a solid understanding of how structural drawings are read. And referring to the structural drawings, we do the modeling of our structure either in Revit or any other modeling software. So in this video, we are going to study how to read structural drawings and what are the different structural drawings that are involved in different stages of construction. So we are going to look at the different stages of construction, and we are also going to see what are the different types of structural drawings that are referred at different stages of construction, along with how to read those structural drawings. Okay, so let's get started with the session. So what are the different stages of construction? So referring to the looking from the structural point of view, we majorly have the foundation stage, the pedestal column stage, the plinth beam stage, then we have the columns, then we have the slab beams, then we have the slabs. We also have retaining walls, and we have shear walls, and there are various other type of structural drawings that we refer to when we are building or when we are executing those structures on site. Okay, so let's get started with this session, that is reading structural drawings and sequence of construction. That is, we are going to see what are the different types of structural drawings that are involved at different stages of construction and how to read those structural drawings. So the very first stage is site cleaning. So whenever you have a site, okay, or whenever you visit the site, you first need to clean the site and level the site. So whenever you go to the site and when you want to do the site cleaning and when you want to mark the boundaries of your site, we refer to the plan. Okay, this is a simple plan which I've taken up. So after that, we have the center line drawings. Now, what are center line drawings? It looks something like this. This, okay. So this is how the structural drawing. This is how the These are how the center line drawings. They look like this. So when we talk about center line drawings, now what do I mean by center line drawings? Now when you go to any site, let's say this is my site. This is my site, okay, and this is the boundary of my site. This is the boundary of my site, just for example. Now basically a structure has two components, that is the substructure and the superstructure. A structure has two components, that is substructure and superstructure. What do I mean by substructure? Substructure is the part of the structure which is below the ground. What does my substructure include? Foundations, pedestal columns, plinth beams. What does my superstructure include? Columns, slab beams, and slab. Okay, we may have retaining walls, we may have shear walls. But we'll just start with the basics first. We'll learn the basic structural components first, how to read the structural drawings of these basic components, and how to model these in Revit or any other modeling software. So let's suppose that these are the boundaries of my site. Okay, now when I have the boundaries of my site defined, when we want to start executing or when we want to start executing the substructure part of the structure, that is we want to lay foundation. Now when we want to lay the foundations, we just cannot randomly excavate we just can't randomly excavate soil in any part of my site. Okay, I just can't start excavating soil here and place my foundation. I just cannot start excavating my soil here or here and start placing my foundation. There are certain specific locations on the site where I need to start excavating my soil. You can see these points that are marked in chalk, okay, in white chalk. These are the, let me just erase this. Okay, let me erase everything first. And if you can see now, wherever I have marked these points here or these areas, this is where my excavation has to be done. This is where my excavation has to be done. This is where my excavation has to be done. Now the location where my soil is to be excavated is being given by my centerline drawing. So centerline drawing is looks something like this. That is, this is the width of my excavation. This is the length of my excavation pit. This is the width of my excavation pit. Okay. Uh, so this is the length of my excavation pit. So this is going to be 6 feet 6 inch, and this is going to be 7 feet. So this is going to be 7 feet. Now how this is 6 feet 6 inch, why this is 7 feet? Now this all comes from structural analysis. Okay, and this is usually given. Okay, the location of the columns is usually given by the architect. It is approved by the structural engineer, and after analysis we the structural designer, he gives us these dimensions. That is, what is the width of the foundation, what is the depth of, what is the length of the foundation, all these dimensions, and the distance between these columns, the distance between the foundation pits, is all given by the structural engineer. Okay, so we can take that up at a later stage, like how we get this as 6 feet 6 inch, how we get this as 7 feet. So these things, right now we'll just focus on the modeling part. This is, we directly get these dimensions from the structural engineer, and we just have to model this in Revit. So what are my centerline drawings? Centerline drawings give us the location of the excavation pit, okay, along with the location of the column, and the distances between the center to center of the column, and the distance between the excavation pits. So this is what centerline drawings give us. So we have centerline drawings which define the location where the excavation is to be done, and in these excavation pits we place a foundation. Okay, so we have discussed one type of drawings now, that is centerline drawings. Now this is how the excavation is done on site for the same centerline drawing. Okay, so the definition is, using centerline drawings we calculate the quantity of earthwork. Okay, so this is what we can take up in some other video, how to calculate the quantity of earthwork using centerline drawings. Okay, that is to be excavated on site so that we can construct the substructure part of the buildings. What is the substructure? Foundation. Majorly for foundations, majorly we use centerline drawings to know the location of our excavation pit, okay, of the building, and using column and footing drawings we calculate the quantity. Okay, we can see this at a later part, like how to calculate the quantity of concrete for columns and other components. Okay, so right now just know that we have the centerline drawings used to locate the excavation pit on site. So this is how the excavation pit looks like. We have got this centerline drawing from the structural engineer, and this is how I'm excavating the, this is how I'm marking the location of the excavation pits on site using the centerline drawings. And now wherever these points which are marked on site, the excavation is to be done here. So this if I talk about this centerline drawing, this is the markup. This is C1. Okay, let's start from here. This is C1, this is C2, this is C2. What is C1, C2? This is the location of, this is the column naming that I've given. This column is C1, this column is C2, this column is C3. We can name the foundation as well. This can be F1, this can be F2, foundation 2, this can be F3, and again C1, C2, C3. Okay, and this is F1. The column here is going to be C1, the column here is going to be C2, the foundation associated with this column is going to be F1, this is associated with C1 is F1, the foundation associated with C2 is F2. So this here is C1 or F1, I can say F1, and the column that will be placed on this foundation is C1. So this is F1. My F1 foundation is going to be placed in this excavation pit. So this is 6 feet 6 inch. You can see here this is 6 feet 6 inch. So this is 6 feet 6 inch, and this is going to be 7 feet. So this is going to be 7 feet. So this is F2 and this is F3. So this is how you read centerline drawings. Okay, know that this is not the dimension of the foundation, this is the dimension of the excavation pit. Okay, how to read the dimension of the foundation, we are going to study that in how to read foundation drawings. Okay, so now you can see here. Okay, so this is another plan that I've taken. Now this is a foundation plan. Now foundation plan, and this is the cross section of my foundation. So if I see C1 here, this is my C1. So this is my F1 foundation. This is my F1 foundation. This is my C2 column. So this is I'm going to have my F2 foundation here. C3, I'm going to have my F3 foundation here. So this is my foundation drawing. So I've not mentioned it here. So this is my foundation plan. It will be clearly mentioned in the drawing that this is my foundation plan. So this here, okay, is going to be 7 feet. So if I talk about, if I show you all a foundation, okay, so this is how a foundation looks like. This is how my foundation looks like. So this is a stepped footing. Okay, so this is the length of my foundation. This is the width of my foundation. This is the width of my foundation, length and width of my foundation, and this is the length of my excavation pit, and this is the width of my excavation pit. If you observe, it is different. Okay, so now, okay, what is the length of my, so this is a different drawing, this is different drawing, and this is different drawing. So here, what is the length of my foundation now? It is 7 feet. So this is going to be 7 feet. And what is the width of my foundation? It is 7 feet again. So this is also going to be 7 feet. And what is going to be the thickness of my C1 foundation? So here it is given so here foundation size is 7 feet 7 feet. Okay, 7 feet 7 inch. Here I've taken this for C1. Okay, this is an example for C1 foundation. Okay, C1 and F1 foundation. So the foundation associated with C1 column is F1. So for F1 you will have this cross section. So for C2 you may have a different cross section given to you, and the depth and length width may be different for that foundation. Okay, for C3 it may be different, for C4 it may be different. So this cross section and these values which I've taken, that is the length, breadth and depth of my foundation, this is particularly for C1 foundation F1 located below C1 column. Okay, so the foundation that is located below C1 column, which we have designated as F1, the length of that foundation is, what is the length of that foundation? The length of that foundation is 7 feet, and the width of that foundation is also 7 feet. Okay, it is 7 feet. So here it is mentioned in the plan as well as in this table as well. So the foundation size is, footing size is 7 feet 7 feet 0 inch, 7 feet 0 inch. Okay, so we learned how to read the length and the width of my foundation, that is 7 feet and 7 feet. Now the depth of my foundation, so here I'm going to get that in the cross section. So what is going to be the depth of my foundation? It is going to be 24 inch flat. Okay, so steel details. Now how do we learn the steel details? So footing steel along both ways. Okay, so what is it? 12 inch. Okay, 12 diameter. Okay, 12 diameter at 6 inch center to center. So it is 12 mm. It is not inch, sorry, it is 12. Let me erase this. So what do I mean by tor? That is nothing but the diameter. Okay, so 12 mm, because in the market you're going to get bars, okay, rebars in the form of mm. Okay, so it is 12 mm at the rate 6-inch center to center. So this is the spacing of my rebars. Okay, so if I see in top view, in B ways is both the ways. So it is going to be, I'm going to take 12 mm diameter bars. Okay, and I'm going to place it along 12-inch center to center. Okay, so this is going to be one rebar here, one rebar here, one rebar here, one rebar here. This is in plan view, one rebar here. Okay, and what is the distance between these rebars? It is going to be 12 inch. Sorry, 12 inch center to center, 12 inch center to center, 12 inch center to center, 12 inch center to center. Similarly, along the other side, the rebars that I'm going to place is 12 mm dia, 12 mm dia, 12 mm dia, 12 mm dia, and the distance between these rebars is going to be 12-inch center to center. Okay, so dia of the bars is 12 mm and the distance between the bars is, it is equal to 6-inch center to center. So what do we need to see in the foundation drawings? First things first, we need to see the length of my foundation, the width of my foundation, the depth of my foundation, and the rebar details. That is what diameter bar is used in that foundation, and what is the spacing between the rebars. In some of the drawings, along the length, okay, this is along the length, you may have a different dia bar and spacing might also be different, and along the width, okay, along the width also you might have a different dia bar along with different spacing. Okay, so since along both ways it is mentioned as 12 mm dia bar at 6-inch center to center, we have the rebar dia as well as the spacing along the length and along the width same. Okay, sometimes we may also have another row here saying found, this might be footing steel along length, this might be footing steel along width. Okay, and here it might be something like 16 mm dia bar or 16 tor bar at the rate 8-inch center to center. So depending upon whatever is being given by the structural engineer, we have to read the drawing accordingly and we have to model it accordingly in the software. Okay, so this is how we read foundation drawing. Okay, so here you can see, okay, so this is the length of my foundation, which was given as 7 feet. Okay, this is the width of my foundation, which was also given as 7 feet. Okay, this is length, this is width is equal to 7 feet, and this is the depth here. Okay, this is the depth of my foundation, which was given as 24 inch, that is equal to 2 feet, that is equal to depth of my foundation. And if you see these rebars, one rebar, two rebars, 3, 4, 5, all these rebars, these are 12 mm dia bars at what spacing? At 6-inch. So the spacing between these rebars is 6-inch, and these rebars here, okay, this was along the width, this was along the length, and these are along the width now, and the rebars that are along the width, these are also mentioned as, if you see the table, this is also, since it is both ways, it is 12 mm dia at the rate 6-inch center to center. Okay, so this is how we read the foundation drawings. Now we learned how to read my excavation pit size, okay, how to locate them, how to read foundation drawings, that is how to read the length, the width, the depth of my foundation, okay, along with the rebar details, that is what is the diameter of my rebar that is to be used along the length, along the width, and what is the spacing of the rebars along the length and along the width. Sometimes we have two mesh foundation, that is we have a mesh at the bottom and a mesh at the top. Okay, so this is called as a single mesh foundation, wherein we only have one mesh here. Okay, and here we have two meshes here. Okay, one and this is two. Okay, so this is double mesh foundation and this is single mesh foundation. Okay, now next is pedestal column. So how do we learn? Now a column spans right from the foundation up to your last level. let's say that you are constructing a two-story building. So the column always spans right from the foundation level up to the second floor or third floor, whatever floor you're casting, okay, whatever floor you're constructing. So when the column is started from the foundation level, from the foundation level up to the plinth beam level, whatever the foundation, whatever column we are having, that column is called as a pedestal column, okay, and the same column continues up to the last floor. But the column that is above the ground, okay, that is called as my column, norm just column, you call it just column. But the column that is from the foundation level up to the plinth beam level, that is called as your pedestal column. So how do we read the column details now? So what we need to learn, what we need to read is, this is my column, okay. So what I need to learn, you can see this is my excavation pit, this is my excavation pit, and this column is coming right from the foundation level, and this is my plinth beam level, okay, this is my plinth beam level. So the column which is below the ground is called as my pedestal column. So what are the details that we need to study from the column drawings? That is the length of my column, the width of my column, okay, and the rebar details, okay. Depth, we don't have the depth of column because it is going to span right from the foundation up to the last floor, okay. So just the length, here you can see clearly, this is the length of my column, this is the width of my column, and these are the rebars, and these are my lateral ties, okay. So these are my lateral ties here, and this is also my lateral tie here. So okay, so group 1, okay, let's say C1, okay, C1 column. So what is C1 column? The column that is associated with my foundation 1, F1, that is called as my C1 column. So let's say, so I have already studied, we have already studied this part. Your PCC size is also given. Now what is a PCC? It is a firm base that is created in the excavation pit over over which your foundation is laying, okay. So we have the PCC size, we have the footing size, we have the depth, okay, of my foundation, and we have the footing details. We have just studied this like few moments back. Now we have foundation to ground slab. Now what is my column details? So from here onwards we are going to study the column details. This is my column detail. So when it comes to column details, now for footing, okay, footing to ground floor slab. Now footing to ground floor slab, I'm going to have a certain size of my column along with the reinforcement detail. So what is that? What is the size of my column? It is 12 inch by 24 inch. So the length of my column is going to be 12 inch, and the width of my foundation is going to be 24 inch. So here it is given. So this is equal to, this is equal to 12 inch, and this is 24 inch. So length and width. Very simple. Now steel. What is the steel use? 12 number of 20 mm diameter bars. 12 numbers of 20 mm dia bars. So 12 numbers. So this is 1, 2, 3, 4. Now what is the dia of these bars that is used in the column? 12 mm. Okay. 12 mm? No, no, no. It is 20 mm. Okay. It is 20 mm. 20 mm. So it is tall 20. So 20 mm bar, and how many numbers there? 12. So this is 1, this is 2, this is 3 and 4. Similarly along the other side, 5, 6, 7, sorry, 5, 6, 7 and 8, okay, and 9, 10, and behind this 11 and 12. So we have 12 number of bars which are 20 mm, okay, 20 mm. And what is the we don't have distance here, okay. So let's suppose we had 8 number of bars, okay, let's say we had only 8 number of bars. So how are you going to place? 3 bars here, 3 bars here, and 1 bar here, 1 bar here, okay. So and then we have lateral ties. So this is 8 mm dia bars at 8 inch center to center. So here you can see these are my lateral ties. Let me erase this. so that I can see it clearly. Okay, so these are my lateral ties here. You can see this. This is what is the dia of these bars? 8 mm. And what is the distance between these lateral ties? This is 8" center to center. So this is also my lateral tie. This is also my lateral tie. This is also my lateral tie. Okay. So this is how you read column drawings. Okay. I'm being very brief. We will see this in detail when we are doing the structural modeling in the software. Okay. So next is my plinth beam. Okay. So you place the pedestal column and you do the backfilling here now. Okay. So this is how you do the backfilling, and you place your uh, plinth beam here. Okay, we are going to place this plinth beam here. Right now I'm not going in detail about the construction sequence. Okay, I'm just focusing on the major structural components and how to model them. Okay, so once we cast a pedestal column, we do the backfilling. We place one layer of PCC or mortar or cement mortar or gravel, and we place plinth beam over this. Okay, so when we talk about a plinth beam, it looks something like this. One second, let me show you the actual picture. So this is how the plinth beam looks like. Okay, so how is this plinth beam casted? First we place a layer of PCC or mortar, or sometimes brickwork, or sometimes any other material, okay, which is available on the site. And then we place these rebars here. You can see these rebars. We place these rebars, we place these shutterings, and then we do, so this is how we place the shuttering, and then we do the concreting. You can see this concreting is done. So what are the things that we need to study in a plinth beam drawing is the rebar details, okay, and the width and depth of my uh, this uh, this is the width and this is the depth of my plinth beam here. Okay, this is the width of my plinth beam, this is the depth of my plinth beam, and this is my reinforcement details here. So how do we read these drawings? We have this here. Okay, so let's say B1 drawing, beam B1. So let's assume this is B1 here. Okay, let's assume this is B1 here. So when we talk about B1, okay, let's say this is B1 here, which they are casting. So this is called as my top reinforcement or top rebar. This is my bottom rebar. Okay, this is my bottom rebar, and these are my stirrups here. These are my stirrups here. So first things first, what is the width of my plinth beam? As we can see here, this is the width of my plinth beam, this is the depth of my plinth beam. So as it is mentioned in this drawing table here, that is the width of my plinth beam is 9" and depth is 15". So this is going to be, this dimension is going to be 9", which is the width of my plinth beam, and this is going to be the depth of my plinth beam. Okay, this is going to be the depth of my plinth beam. Width of my plinth beam is 9". So this is 9", and depth is equal to 15". And rebar details. Let's come to the rebar details now. So what is the rebar details? Bottom reinforcement. This is the bottom reinforcement. This is the top reinforcement. Okay. So what is my bottom reinforcement? 3 number of bars. And what is the dia of my bars? This is 12 mm. Okay, 12 mm. Dia of my bar is 12 mm and the number of bars is 3. So here you can see very clearly. So let me erase this. So this is 3 number of bars at the bottom. 1, 2 and 3. Okay, here you can see 1, 2 and 3. Okay, let's consider this as B1. So 1, 2 and 3. And what is the spacing between these bars? It is, we don't have the spacing here, it is just mentioned. Okay, here so it is 3 bars, so you have to place 3 bars evenly. Okay, and then we have top reinforcement. Okay, top reinforcement is also 3 bars. So top we at the top we also provide 3 bars. Here only 2 bars are provided. We have just assumed this as B1. Okay, so 1 bar, 2 bar, and maybe one more bar will be provided here. Okay, um, so we learned how to read bottom reinforcement bars, top reinforcement bars. Now the stirrup spacing. Now what is stirrups? What is the dia of my stirrups? This is 8 mm. 8 mm dia bars. And what is the distance here? 8 inch center to center. So here you can see. So the dia of these bars here is 8 mm. 8 mm. And what is the distance between these stirrups? That is 8 inch center to center. Sometimes what happens is at a certain distance at a certain distance near the face of the column we usually have lower spacing. Okay, reason being more shear is exerted here. So here we have near the face of the column and at the center span. Here you can see I have one column here, I have one column here. So at a certain distance from the face of the column which is given in the structural drawings, we have lower spacing. So let's say this will be S1, and for the rest of the beam, that is at the central span of the beam, we may have a different spacing. But for this drawing we have same spacing, 8 dia bar at 8 inch center to center, 8 mm diameter bar at 8 inch center to center. But you might have a different set of drawing wherein you have different spacing near the face of the column and a different spacing for the central space, the center of the column. Okay, central span of the beam. Okay, so this is how my plinth beam looks like. Okay, this is how my plinth beam looks like. So this is how the schedule looks like. After the plinth beam, we have column again. So we already know how to read column drawings. Once we know how to read foundation drawings. Now, what we have learned till now is we have learned how to read foundation drawings. We have learned how to read pedestal column drawings. We have learned how to read plinth beam drawings. Now we will now above the plinth beam we have columns. Okay, so this process is same as we read the drawings for pedestal columns. And how to read my slab beam drawings? What is a slab beam? The beam that is below the slab is called as my slab beam. The process is similar. That is, then the backfilling is done, and then we have ground floor beams and levels. Okay, so this process is same, like how the process that we just followed to read the plinth beam drawings, the same process we use to read the slab beam drawings. That is how to read the beams below the slab. Along with this, we have certain additional reinforcement like top extra, bottom extra, that we will see. Since we are just covering the basics now, we will see that in a later part whenever we are doing the modeling in BIM or in the Revit software. Okay, in Revit software. So here what we have is lintel and beams, and then we have staircase reinforcement. This also we will see when we are doing the modeling in software, in the software. Okay, and then okay, this is what I wanted to show you all, how to read slab beams. Okay, let's do one thing. We'll take this up in the next session. Okay, how to read staircase drawings. Okay, and how to read slab drawings, and then we will start off with the modeling in any of the softwares. We will take up Revit software and we will see how to refer the structural drawings and how to do the modeling in Revit software. Okay, so this was it for today, and I will catch you all up in the next session. Thank you.